In geology, sometimes old-fashioned map techniques are still used to identify elevations, locations, and features. So when you're learning about maps in geology, it's going to be very different of your application of maps in everyday life. You're probably really used to using the GPS on your smartphone or built into your car to navigate yourself places, and I don't know that you'll ever need to use a paper map to find something. But in geology, we still use it, so in this course we're going to go over latitude and longitude, how to use and identify those coordinates, what the different numbers mean, and how it differs from digital interfaces when you're using maps such as Google Maps or GPS. So latitude and longitude, I say them in that order because whenever you write down coordinates, you write down the latitude first and the longitude second. So latitude and longitude are just ways of coordinating yourself or locating something on a 2D map. So you may remember from math classes perhaps in middle school or elementary school when you would have to graph something along an x and y axis. And so you would find the x number first along the horizontal plane, and then the vertical axis, the y-axis, you would find that number second, and then you can find a specific point on that map or on your graph. So you can do the same with latitude and longitude. However, latitude and longitude is showing a spherical plane rather than a flat 2D plane as you would have with graphing in math classes. So you have to start to visualize, how do we divvy up a sphere into something that can be interpreted in a 2D format. So there's two ways that cartographers had chosen to do this. And so both of them rely a little bit on your knowledge of angles, a little bit of geometry. So when we're looking at north and south, that's what we do latitude in, is north and south. We're looking at bands that go up and down the planet, going around the planet, but these bands or rings are numbers that you would find going up and down or north to south, and they'll tell you how far you are away from point zero, which is the equator. And so to remember that latitude goes around, I always think of latitude, fatitude, and I visualize, what if the planet is like a little guy, this is a little person, and if you're thinking latitude, fatitude, then going around the middle, it'd be the fattest part, and so going around the middle, we would have like the equator would be the belt, and then the latitudes are then belts or rings up and down the planet. So here I have my little guy, and then I also gave him a North Pole for his top there. And so latitude, fatitude, remember that the latitude goes around the planet. Those are the rings around the planet. And so you probably can't see it very well, but on my whiteboard back here, I have 0 as the equator, and then I'm moving into geometry. If you recall geometry very much from, I don't know, was it 9th grade or something, you would know that if you do a right angle from a flat plane, it's going to be 90 degrees. And so when you're looking at the North and South Pole, those would be oriented along the 90-degree plane from the equator. So you have the equator is the 0 middle line, and then up and down, running 90 degrees or perpendicular to that, you have your north and south. And so the places in between that, the 0 up to the 90, you can have like a 45-degree angle, 30, 60. And so I wrote up on the board there the different degrees, but I also have a little visual aid here where you can see, moving from the equator, which is the, remembering latitude, fatitude, that's the one that goes around. And so moving up from the equator, you have the 30 degrees mark, 45 degrees mark, and 60 degrees mark. And now these ones are saying north because they are going to go north of the equator, but of course I could have written, south on them and done the 45 degrees south or 90 degrees south. So when we're thinking of latitude, the maximum degrees you can have, those angles, the maximum degrees you can have in latitude is going to be 90, because once you hit to the perpendicular of the north and south, and then you start tipping over past the other point, it's going to return to 60 degrees, 45, 30, and back to 0 as you move back toward the equator. If you ever hear people say high latitudes, they mean high numbers. So often when we're looking at the map, we orient north at the top. And so you might think high means up, and you might think high latitudes equals anything north, and then think low means south. But really high latitudes means a high number of steps away from the equator, be it in the upwards or downwards direction we're looking at a map. So high latitudes just means a high number up to 90, whilst low latitudes would be equatorial region, the tropics, which would be nearer to the equator. So that's latitude. Those are the rings that go around the planet like a little belt. And then we have longitude. And longitude is now, if you were to cut the planet in half and look at the full circle of the planet, you would then have 180 degrees. This one here we see 0 to 90. But a circle, if you go all the way around in a circle, and I have like a little desk compass here that you perhaps used when you were in geometry courses, you see the maximum number is 180. As you go all the way around a circle from 0, if you do a full 180, you're facing the opposite direction. Versus 360, you'd spin all the way around. And so these degrees for the longitude, the bands that go the other direction, for east and west, here we go, longitude, these degrees, our minimum is then going to still be 0. And the maximum, rather than 90 as we have with latitude, our maximum is 180 because you can turn a full circle. Once you turn past that full circle, you start approaching 0 again, and then the numbers would count back down from 180 to 0. So the 0 point was established when England had control over all of their now former colonies. And so their waypoint in their maps would be where they were, 0. It's also referred to as Greenwich Mean Time, or the prime meridian. Greenwich Mean Time is GMT. So that's sort of the 0 point. And then the opposite, 180, it wasn't selected for any specific reason. It just geometrically was the exact opposite point. It's antipodal, or opposite pole, of where the 0 point was. So on the opposite side is 180. And it runs almost right through Fiji. It's fairly arbitrary exactly where the 180 was. It was just opposite of where the 0 was, but it's now roughly along the international date line. International date line weaves around a few countries as not to split one country across two dates, but it's roughly along the international date line, whilst 0 is prime meridian, or Greenwich Mean Time, GMT. So when you are looking at your degrees for coordinates, the degrees for north and south, you have the parameters of the minimum being 0, of course, and the maximum is 90 degrees. Whilst for east and west, the 0 is the minimum, and 180 degrees is the maximum. And a good way to remember that east and west extends further numerically than north and south would is like you never really hear things as being like the middle north or the middle south. But you have heard of the Mideast. And so if you're looking at 0 for GMT and you go midway to the maximum of 180, you go midway, that's roughly where the Middle East is. And although in the United States we call our Midwest for other historical expansionary of the US reasons, our Midwest is roughly around the middle point. It also goes through New Orleans, the 90 degrees line. Our Midwest is roughly around the middle point as you go to the maximum number for the West. So if you think of stuff like that, you hear like Mideast or Far East or the Western world, that's spread out around the globe along those lines of longitude. So for latitude and longitude, the first number or unit you would use, the biggest number, would be degrees. And so the degree lines, if you're going between roughly England and Bangladesh, that's 90 degrees. But you're not going to just count, 1 degree or 2 degrees as your units. You're going to have to divvy those up to even smaller numbers if you're going to be really exact of where a point is. Because again, if you're going from 0 at the equator, or 30 is roughly where California or Southern California is, you've got a huge span of difference between 29 degrees and 30 degrees, or 28 degrees and 29 degrees. So you have to make it even more finite. So divvying it up even smaller, you get into these more minute, like getting into the minutia of something means it's smaller, you get into these more minute measurements. And so that brings us now to, we just say the word minutes, and we automatically think time with minutes, but it just means a smaller unit. And that makes sense when you think of the word minutia as it's just smaller. And so for every 1 degree, it's divvied up into 60 minutes. And that's pretty easy to remember because you probably use time, unless you're late to everything, I guess. But if you use time An hour is broken up into 60 minutes. And so just like with minutes, even though there's 1 minute, 2 minutes, and maximum of 60 minutes an hour, you would never really refer to 60 minutes. You would then switch to saying hour. And so when you're denoting minutes, even though there's 60 in 1 degree, 60 minutes in 1 degree, your maximum number of minutes you're going to say per degree, you're going to say maximum at 59, because once you get up to 60, it kind of rolls over to the next degree. So my little examples here is if you're trying to tell somebody, hey, meet me here in 2 hours. You wouldn't say, meet me here in 1 hour and 60 minutes, because that would be really ambiguous. They're like, why are you saying it like that? Instead, you would say 2 hours and 0 minutes. So yeah, maximum is 60. That's how much you fit in it. But the most you would denote would be 59 before you start writing in the next degrees. So for minutes, we have in 1 degree, you have 60 minutes. And then it's further broken down into seconds. And it stays being pretty easy for us time users, because in seconds, and this now just means second, it's this second, like second in an order of we're going smaller. That's sort of like the city of El Segundo. It's the second city. It's smaller than LA, so it's like the second next one or whatever. So this second one, we're so used to it being times, but it's the next in sequence of becoming smaller and smaller. So we go minutes to seconds. And just like minutes and seconds in time, we have 60 minutes and 1 second. So those terms, that vernacular is familiar to you, and those numbers associated with it is also familiar to you, and that's great. But the way we denote it, we're now mixing up seconds and time with distances. I guess that makes sense because it's coordinates. So hopefully you're not getting too lost here when I want to tell you that although degrees has the little circle like we use for degrees and temperature, minutes and seconds use those little apostrophes you might use if you write things in feet and inches. So if you write, 5'2", it would be 5 with like a little single line, because that's what we use for the feet is the single line. And then in inches, we move to the double lines. And so for minutes and seconds, we do the same thing. So you denote the degrees in the little circle. Minutes is just one of those little apostrophes. And then in seconds, you do 2. So I know it's not an apostrophe, but yeah, it's like the same sort of little curved punctuation you might use. And so in seconds, again, you have the maximum of 59, even though there's 60 seconds in a minute. So those are the numbers we use in coordinates.